Praise the Lord. Hello, everybody. Welcome back to the final session on the chapter of mathematical induction. Dear students, in the previous two sessions, we have solved almost 10 questions on the chapter of mathematical induction. Today, we are going to solve a few of the difficult or challenging questions from the chapter, and this would be the final session on the chapter of mathematical induction. So, you can see already in the view that was the question. This is the question I had given you as a homework. Okay, hope you might have worked it out very well. Okay, hope you don't have any doubts in this. In case you have any doubts, you can refer to the paper which I have already given you. It's better if you can take a screenshot of this and you can take it down later, or it is better if you can write it down now itself. So yeah, so that's it. Let's go to the first of the challenging questions for the session now. Are you ready for it? Okay, let's go for it. So here comes the first question, dear students. The P of n statement is nothing but 1 into 2 plus 2 into 3 so on up to n into n plus 1 should be equal to n into n plus 1 into n plus 2 divided by 3. Okay, now you are very familiar with all the steps of the mathematical induction. So you know the first step. So what is the first step you are going to see? The first step you are going to do is to prove P of 1 is true. Again, once we do this, we go with LHS. What is LHS? We know LHS is 1 into 2. 1 into 2 would be 2. Okay, so RHS, why I am rushing through is nothing but because you know this concept very clearly. I've just take you through the difficult steps itself. So please note it down. I'm going to just work out the third step in most of the questions in this video because the step 1 and step 2 are self-explainable. Okay, now look at the RHS. So it is 1 into 1 plus 1 into 1 plus 2 divided by 3. So if you multiply, so 1 plus 1 will give you 2, 1 plus 2 will give me 3. Now 3 and 3 gets cancels. You will get 1 into 2 is 2. You can easily see here LHS is equal to RHS. Therefore your P of 1 is true, isn't it? So your first step is clear. Now moving on to the second step, we all know it is the step of assumption. So we assume P of m is true for some m belongs to n. Okay, so as soon as you see this step, you don't do anything, just replace this statement wherever you have n, you just replace it by m. Okay, so quite simple step it is. 1 into 2 plus 2 into 3 up to m into m plus 1 should give you m into m plus 1 into m plus 2 divided by 3. As you all know, we are just going to replace n by m. Nothing much to do with step 2. Now the most important step, moving on to the step 3. So step 3 will be to prove P of m plus 1 is true. Is it clear? Now as we know it, for what we are going to do here is we are going to add the term. So what is the term you're going to add? Just look at the right hand last term in the RHS. So the last term in the RHS is n into n plus 1, or here you can check m into m plus 1. So just replace m by m plus 1. That would be the term you will be adding. So if I put m is equal to m plus 1, first term would be m plus 1 into, here if you put m is equal to m plus 1, I have another plus 1. So I will get m plus 2. Is it clear? So the next term of this sequence would be m plus 1 into m plus 2. So the idea behind adding is nothing but adding the next term of the given sequence. Is it clear? So adding m plus 1 into m plus 2 on both sides of equation star. So what happens when you add is nothing but just let us write down the steps. So you have 1 into 2 plus 2 into 3 will go on. Okay, where up to plus m into m plus 1, isn't it? As we know, to this term we are going to add the next term, which is m plus 1 into m plus 2. So my LHS is clear. So actually this will be equal to, one term is already present in the RHS, so it is m into m plus 1 into m plus 2 divided by 3. To this term in the RHS, I'm going to add my term m plus 1 into m plus 2. Okay, it's quite clear here. Now we all know, it's very clear in both the terms. I have m plus 1 into m plus 2 as common. Write down the leftover terms. First term you have just left over with m by 3, and the next term both the terms is taken outside, so leftover term is nothing but 1. Please don't make the mistake of taking 0. Okay, so since everything is taken outside as a common, you will be left over with constant 1. So this would be nothing but m plus 1 into m plus 2. If you take the LCM, 3 would be the denominator. So m plus cross multiply, you'll get 1 into 3 is 3. Okay, we are almost come to the conclusion of this question. So I'm going to rewrite this step as m plus 1 into this m plus 2. I'm going to write it as m plus 1 plus 1. Okay, similarly, this m plus 3, I'm going to write it as m plus 1 plus 2 divided by 3. So why did I make these changes? Just to match with my RHS in the general term. So you can check there, each m plus 1 is replaced by n, or each n in the general term is replaced by m plus 1 in the RHS of the step 3. So this is sufficient to say that P of m plus 1 is true. So that concludes our step 3. So once the step 3 is cleared, we have just left over with writing the conclusion, which is again a regular conclusion which we use from 1, 2 and 3. We have P of n is true for all n belongs to n. And that concludes our proof. Okay, it's a very simple problem, though it may look complicated, but you have to work it out clearly, only then you can solve it. Okay, so that was all about the first question. Let us take the similar question now. Fine, so here comes the next question. You can note it clearly. Each term is a multiple of 3 terms. You can see here, first term is 1 into 2 into 3, 2 into 3 into 4, so on, up to n into n plus 1 into n plus 2. This I have to show it as n into n plus 1 into n plus 2 into n plus 3 by 4. Okay, so as we all know, let's start with step 1. Step 1 is very clear, obvious one, to prove P of 1 is true, isn't it? So what is LHS? So we know how we prove it. LHS of step 1 is, take the first term, it is 1 into 2 into 3. So what is 1 into 2 into 3? It is 2 3s are 6. Now moving on to RHS, you can check it carefully. Put n is equal to 1, so it is 1, 1 plus 1, 1 plus 2, 1 plus 3 divided by 4. So this is replaced as 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. Now you can cancel 4 and 4 in numerator and denominator. You are just left over with 1 into 2 into 3. That's again nothing but 6. Quite simple. Okay, that is why I've already made it as a ready-made answer. Okay, so that it does not occupy the space in the video. You can work it out by your own self. So once that is clear, you know, you will just write the conclusion for step 1, which is LHS equal to RHS. Therefore, we say P of 1 is true. Fine. So going on to the step 2, which is one of the simplest step. The step is to assume P of m is true for some m belongs to n. Is it clear? So here you have nothing to do. Just replace the given statement as it is by putting n is equal to m. Okay. We have not done any changes. Only one change is replace n by m. Okay. And once you get an equation, we will consider the given equation, the second step equation as equation star. Is it clear? Fine. Hope you don't have any doubts in this. Moving on to the most important step, which is step 3. And again, we know the step 3 is nothing but to prove the next term of P of m, that is P of m plus 1 is true, isn't it? And now, as in the previous cases, we are going to add the terms because each term is addition of, this is additive series. Now, what is the term you're going to add? Just look at the last term. You have to take the next term. That is easily nothing but put m is equal to m plus 1. So we know each term is a product of 3 terms. So out of the 3 terms, first term would be m plus 1. Now next one is m plus 1. Again, if you replace this m by m plus 1 will give me actually m plus 2. Similarly, m plus 2, the next term would be m plus 3. Okay, if you understand this step, then you have done with 60% of the work. So adding m plus 1, m plus 2 into m plus 3 on both sides of equation star. So what is left over now? We have 1 into 2 into 3 plus 2 into 3 into 4, so on, up to m into m plus 1 into m plus 2, isn't it? This term is already there. To this term, I'm going to add m plus 1 into m plus 2 into m plus 3. Fine. So this will be equal to, I'll write the RHS here. This will be equal to, I have already RHS is nothing but m into m plus 1 into m plus 2 into m plus 3 whole divided by 4 plus the term I'm going to add, which is m plus 1 into m plus 2 into m plus 3. Isn't it very simple? Yeah. So what we can do it is, now can you can, it's already visible. It's quite clear here. What are the terms you can take common? In both the terms, I am left over with m plus 1 into m plus 2 into m plus 3. So if you take this common in both the terms, in the first term you are left over with m by 4. In the second term, everything is taken common. So just 1 is remaining. Okay, fine. So this is nothing but I have m plus 1 into m plus 2 into m plus 3. Nothing, no more changes here. Here I'll take the LCM, denominator will be 4. This will be nothing but m plus, if you cross multiply, you will get 1 into 4 is nothing but 4. Okay, you have almost approached the conclusion of the third step. So see how I'm going to rewrite this step as m plus 1 is written as it is. M plus 2 I'm going to write it as m plus 1 plus 1. Okay, similarly m plus 3 is nothing but, you can take m plus 2 plus 1, but better always take m plus 1 plus the remaining number. Okay, 2. Finally m plus 4 can be written as m plus 1 plus 3, because 3 plus 1 will give me 4, whole divided by 4, because if it is denominator of each term, because it is a multiplication product of terms, you can take a common denominator. Now you can check with the general term there. So n is replaced by m plus 1 in each term. So m plus 1, m plus 1 plus 1, m plus 1 plus 2, and m plus 1 plus 3 divided by 4. Okay, so what is this? This is what I wanted. So this concludes the third step, stating that p of m plus 1 is true, isn't it? Once the step 3 is clear, you are just left over with writing the conclusion, which is nothing but from 1, 2 and 3, we have p of n is true for all n belongs to n. Okay, so that will be our required proof. Isn't it simple? Well, let's go to the question number 3 for the session. So here comes the question, dear students. This is similar to the previous question. There you had the product of 3 terms in the numerator. This is the product of 3 terms in the denominator. Okay, in the previous session we have seen the product of 2 terms in the denominator. This is the extension of that problem. Okay, so given statement, we are going to take it as p of n and we have to prove it. Quite natural. Step 1 is equal to prove p of 1 is true, and going on to the LHS, you can take the first term, that is 1 divided by 1 into 2 into 3, that will give you 1 by 6. Okay, so now proceeding with your RHS, that is put RHS n is equal to 1 in each value here. It is 1 into 1 plus 3 divided by 4 into 1 plus 1 into 1 plus 2. So it's just the simplification. 1 plus 3 will give me 4. This 4 is replaced. 1 plus 1 is true and 1 plus 2 is 3. When you cancel 4 in the numerator and denominator, you are left over with 1 divided by 2 into 3, that is 6. So you can, it's easily seen there, your LHS is equal to my RHS, hence P of 1 is true. Okay, so that concludes the simple step, which is step 1. Here comes the step 2, which is the most simplest one, which is to assume the P of m is true for some m belongs to n. Okay, in this step we don't have anything much to do, just by replacing n by m from P of n. Okay, so once you replace it, we are going to consider this equation as equation star. Is it not? Fine. So moving on to the very important step, which is step 3, where we have to prove the same result holds good for P of m plus 1. That is to prove P of m plus 1 is true. Clear? Fine. So as similar to the previous step, since each term is added here, I'm going to add the term. See, please be careful how you're going to consider the term. It is very similar to the previous one. So you have to add the next term on both sides. So next term is just a replace m by m plus 1. So m will go to m plus 1, m plus 1 will go to m plus 2, and m plus 2 will go to m plus 3. Okay, so this is the term I'm going to add on both sides of equation star. Once we know what is the term you're going to add, let us start the simplification. So it is 1 divided by 1 into 2 into 3 plus 1 divided by 2 into 3 into 4 going on up to I have 1 divided by m into m plus 1 into m plus 2, isn't it? To this term I'm going to again add the next term, which is m1 divided by m plus 1 into m plus 2 into m plus 3. So this is nothing but my LHS. My RHS will be, write down the term which is already in RHS, m into m plus 3 divided by 4 into m plus 1 into m plus 2. Okay, so to this term, let me add the term which is required, which is 1 divided by m plus 1 into m plus 2 into m plus 3. Okay, so this will be nothing but, now check for common terms. So common terms is in denominator. Two terms are common, which is nothing but 1 divided by m plus 1 into m plus 2, isn't it? So write down the remaining term. In the numerator you are left over with m into m plus 3 divided by just 4, isn't it? Now plus 1 divided by, now two terms are already outside, you are just left over with 1 divided by m plus 3. Okay, so let's take the LCM now. So if you this term is replaced as it is. If you take the LCM, we know the denominator would be 4 into m plus 3. Okay, so let me cross multiply this term. So it is m into m plus 3 into m plus 3. It is actually m plus 3 whole square plus 4 into 1. That is nothing but 4. Is it clear? So this will be nothing but, let's take the next step. 1 divided by m plus 1 into m plus 2 is a very simple term which is outside. Let us not disturb it. Denominator, again no disturbance here. It is m plus 3, 4 into m plus 3. Now if you solve this, let me use a plus b whole square into m. So you will get m square, a square plus b square plus 2ab. So m square means m square into m will give me m cube. Okay, plus 2ab. 2ab will give me 6m. So 6m into m will give me 6m square. Okay, plus 3 square is 9. So 9 into m will give me 9m. Okay, plus a constant 4 is left over. Let me take it as it is. Is it clear? Moving on, you are left over with 1 divided by m plus 1 into m plus 2. Okay, so this is nothing but, here you have 4 into m plus 3 as it is. Now I'm going to give this work for you to factorize. I'll give you the final answer. Though it's a cubic equation, it's up to you how you're going to factorize. Is it clear? You can either use the division method or the synthetic division method. Okay, by using that, you are going to get the terms. If you factorize this, you are going to get m plus 1 into m plus 1. So you will get three terms. So m plus 1 into m plus 1 into m plus 4. So these are the terms you will be getting. If you cancel the common terms which can be cancelled, so you will be left over with m plus 1 into m plus 4. So I'm going to write this as m plus 1 into this m plus 4. I will write it as m plus 1 plus 3. Okay, divided by, what is left over here? Let me write this constant 4 first. Okay, this m plus 2 I'm going to write it as m plus 1 plus 1. Similarly, m plus 3 can be written as m plus 1 plus 2 as we usually write it. Now if you can compare this with the general term here, you have got all the terms where n is replaced by m plus 1, isn't it? So this will conclude the step 3 to prove p of m plus 1 is true. So I've written the third conclusion where P of m plus 1 is true, and I will leave you the conclusion part. You can write it out in your notes, which is nothing but from 1, 2 and 3 we can say P of n is true for all n belongs to n. Okay, so this will conclude the solution for this particular question. Fine. Okay, let's move on to the question number 4. Okay students, from here starts 3 more different varieties of question which we can use by using the principle of mathematical induction. You can see the given statement is not the sum of the terms, it is actually the product of the terms to be equal to n plus 1. Okay, need not worry, whatever the statement is, take it as p of n, and as usual step 1 is nothing but to prove p of 1 is true. Even here not much change in the first step. So first step, your LHS is take the first term which is 1 plus 1 by 1. We know 1 by 1 is 1. If you add up, it will go, you will get 2. Similarly, if you take your RHS, put n is equal to 1 in the RHS term, so you will actually get 1 plus 1, and 1 plus 1 is quite clear, it is 2. Now you can see there your LHS is equal to RHS, hence we can conclude the first step is clear, that is P of 1 is true, right? Moving on to the step 2, which is quite simple. We are going to assume that P of m is true for some m belongs to n. Okay, here I don't have much work to do. Just by replacing n by m, you are going to get some equation, and we are going to name that equation as equation star. Okay, since these steps are self-explanatory, I'm not going to take you much with the explanation because I hope you can easily follow these steps, right? So step 2 is also, we have done with it. Let's move to the most important step, which is the step 3, where we have to prove the next term of P of m, that is P of m plus 1 is true. Fine. So please note down, this is a very important procedure now. So now in each of the problems we have dealt until now, it was the sum of the terms. So since this is equation is the product of the terms, here the next term what we are going to do is not add, we have to multiply. Is it clear? Please note down. So please note it down. Don't make a mistake of taking adding. We are going to multiply. Are you following? So multiplying, what is the term I'm going to multiply? But the term you're going to multiply is similar to the previous steps. The next term is nothing but it is 1 plus is common, 1 divided by m. Just replace m by n plus 1. You are going to get this. So this is the term you're going to multiply, which is 1 plus 1 divided by m plus 1. Is it clear? Just put m is equal to m plus 1. Whatever the term you're going to get, we're going to multiply that term on both sides of equation star. So see what happens if you multiply. Let's take over the terms which are already present. 1 plus 1 by 1, 1 plus 1 by 2, multiplying so on up to 1 plus 1 divided by m. This is already present. To this I will multiply 1 plus 1 divided by m plus 1. Is it clear? Fine. So this is nothing but m plus 1 is already there. To this I am going to add 1 plus 1 divided by m plus 1. Is it clear? Fine. So let us simplify. This is nothing but, I don't have anything to do with LHS. It is clear. So m plus 1 plus, if you take the LCM here, actually you are going to get, sorry, this is multiplication. I'm very sorry. Sometimes even you make a mistake. Please make sure this is not addition. It is multiplying. Is it clear? You are going to multiply. So if you take the LCM here, 1 is multiplied by m plus 1. So it is m plus 1 plus 1 divided by m plus 1. Are you following? So you are left out. Now you have numerator m plus 1 outside, denominator m plus 1 here. These two terms gets cancels. You will be left over with, don't simplify. Let me keep it as it is, m plus 1 plus 1. Okay. Actually, we have done with the solution because look here, the RHS of the general term is n plus 1. We have to get in place of n, m plus 1. So we have to get m plus 1 plus 1. We have already got. So this is sufficient for us to say P of m plus 1 is true. So once you say that P of n plus 1 is true, we know all the three steps are cleared. We have to conclude the solution and hence complete the solution. Okay, so let us write the conclusion. So hence the conclusion, using 1, 2 and 3 we can say P of n is true for all n belongs to n. That concludes the proof for this particular question. As I told you, dear students, this is a variety of question compared to whatever we have solved until this question. Okay, so the remaining two questions would also be a challenging one. Let's take one by one now. Now look at this statement, dear student. P of n is equal to 2n plus 7 strictly less than n plus 3 whole square. Until now, we have solved all the statements where we had, it was all equations. This is an inequality. Okay, we are going to see these terms or this concept in detail in the chapter number 6. But for meanwhile, for time being, let us just consider it as an inequality, because if less than or greater than or strictly less than and greater than is there, such kind of statements are called inequalities. So this we have to prove this inequality by the process of MI, which is mathematical induction. Right, moving on to step 1. Step 1 is quite clear. P of 1 is true. We have to prove it. Now how you are going to prove it is nothing but consider P of 1. Okay, you cannot take LHS and RHS. They are not going to be equal. Put n is equal to 1 in both simultaneously. So you can put 2 into 1 is 2 plus 7. That should be strictly less than n is nothing but 1. 1 plus 3 whole square. Okay, so we know, definitely know, 2 plus 7 is equal to 9. No doubt. And 1 plus 3 is equal to 4. 4 square. Now you can check it. 9 will definitely be strictly less than 4 square, which is 16. No doubt, isn't it? So hence we can say P of 1 is true. So procedure is same, but steps are quite different from the previous problems because the equation is different. When the question is different, we have to go for the different process. So as the disease is different, we are going to give the different vaccines or different tablets, isn't it? In the same way. Moving on to the step 2, here nothing much to do. As usual, we are going to assume P of m is true for some m belongs to n. Again here, you don't do anything, just replace n by m and keep it as it is. That is 2m plus 7 would still be strictly less than m plus 3 whole square. So this term, take it as equation star. Fine. Right, moving on to the most important step, which is step 3, where we have to prove P of m plus 1 is true. Fine. Are you ready for it? Okay. So please note down, this is a very important procedure because here we are going to follow different steps as we have not followed in any other problems. Here the steps are quietly different than compared to the previous problems. Is it clear? So let's start it. Fine. So what do you mean by proving P of m plus 1 is true? Actually, we have to prove 2 into m plus 1 plus 7. Okay. This should be strictly less than, you have to show m plus 1 plus 3 will should give me m plus 4 whole square. Okay. This is what I have to prove. Again, I'm telling you, this is what I have to prove, isn't it? So let us consider. So please look here. Let me consider the next m plus 1 term here. So if I consider 2 into m plus 1 plus 7. Is it clear? Now I'm going to rewrite this as 2m. This is actually 2m plus 2 plus 7, isn't it? Okay. Therefore, I'm going to write this as 2m plus 7. Okay. And I'm going to write plus 2. From equation star, please note down this step. From equation star, 2m plus 7 is strictly less than m plus 3 whole square, isn't it? So if that means if I add 2 on both sides, I'll get 2m plus 7 plus 2 will strictly be less than m plus 3 whole square plus 2. Are you following? These type of reactions you are going to see in detail in chapter number 6, where we deal the concept of inequalities in detail. Okay, so that means when you add a constant term on both the sides, the inequality does not change. Okay, So let us, now this is equal to, remember I'm writing this step is equal to, let us expand. So it is a plus b whole square, it is m square plus 2ab will give me 2 into 3 is 6. 6m plus 3 3 is a 9. Okay, so this is plus 2. Okay, so this will be nothing but, if you simplify this, you will get m square plus 6m plus what is 9 plus 2, that will give me 11. Is it clear? Now please note down this step. M square plus 6m plus 11 will be strictly less than m square plus 6m plus 11 plus 5. Okay, this is a special problem. This is the only way we'll do it. Okay, this is the only simplest way. Okay, so if I add 5 to this, so this term would be less than this added term. Quite clear this is. So this, that means, so this term would be strictly less than, if you add up you will get m square plus 6m plus 16. Okay, now if you can simplify this, it's up to you. You kindly factorize using the factorization process. So if you factorize this, well, small change dear students, along with 5 we're going to also add 2m. Okay, so that I have to get back my original procedure. Okay, I have to get back my conclusion. To reach the conclusion, sometimes I have to make some arrangements. So if I add 6m plus 2m would give me 8m. Okay, so I have m square plus 8m plus 16. Simplify this. If you want, let us simplify here. So you'll have m square plus 8m plus 16. Okay, so this is actually nothing but a square plus 2a into b. You can see here. Okay, plus you can say this is, sorry, this is nothing but it will be 4, because 4 2s will give me 8. So this is nothing but 4 square 16. Therefore I can write this as m plus 4 whole square, isn't it? So I'm going to use this here, m square plus 8m, sorry, this is, please note it down, m square plus 8m plus 16 can be written as m plus 4 whole square. Okay, therefore see what happens. Therefore actually I started with 2m plus 7, okay, plus 2. This is actually nothing but 2m plus 1 plus 7. Okay, this is strictly less than m plus 4 whole square, or I can further write it as 2 times m plus 1 plus 7 is strictly less than m plus 4 whole square. From this I can say, therefore p of m plus 1 is true. Once the third step is cleared, only we are left with writing the conclusion saying that p of n is true for all n belongs to n. So that is the conclusion for this question. Once that is clear, we have done with the complete solution. Okay, fine. So let's move on to the one last question for the session and also the chapter. So here the most challenging question, this is p of n is equal to 10 power 2n minus 1 plus of 1 is a multiple of 3. I have to prove this. Step 1 is quite clear. To prove p of 1 is true. Okay, so let's solve. What is actually p of 1? P of 1 is nothing but 10 power, let me put n is equal to 1. So it is nothing but 10 power 2 minus 1 plus 1. What is actually this? So 10 power 2 minus 1 is actually what? 10 power 1, isn't it? So 10 power 2 minus 1 is nothing but 10. 10 power 1 plus 1. Okay, so this is nothing but 10 power 1 is 10 plus 1, which is nothing but 11. Sorry students, I made a small correction in the question. I had told you it was divisible by 3. It was multiple by 3 was the question taken, but it was wrong. It should be divisible by 11. So you can see here p of 1 I got 11. Therefore p of 1 is true. Why it is true? Because 11 is divisible by 11. Is it clear? Is it not? Okay. So step 2 is an obvious step, which is nothing but the step of assumption. So what we are going to assume? Assume the same thing. So what is the thing we are going to assume? 10 power 2m minus 1 plus of 1 is divisible by 11. This is what we are going to assume. Now, what do you mean by something is divisible by 11? That means this term 10 power 2m minus 1 plus of 1 should be 11 into some constant which has to be divided. Let me take it as d, 11d, okay, where this d will belong to some natural number. Okay, I'm going to consider this as the step equation star. Okay, very important step, please consider this. Because this is divisible by 11, I'm going to consider it as 11 times some constant d. Okay, so let's go on. That's it with step 2. Let's go on to the step 3. So please note down this step, dear students. Now to prove p of m plus 1 is true is the third step. Let me consider p of m plus 1. That is nothing but I will consider 10 power 2 of, in place of m I will take m plus 1 minus 1. Is it clear? Plus of 1. Okay, I just considered the LHS what I wanted for m plus 1 term. Okay, so this will actually be equal to, so what happens to this? So this is equal to 10 power, you will get 2m plus 2 minus 1 plus of 1. Okay, so this is nothing but I'll get 10 power, I will take this as 2m minus 1 into 10 power 2. I'm splitting the terms, please be careful. 10 power 2m minus 1 into 10 power 2 plus of 1. Is it clear? So why I split this is nothing but I will use this. Okay, so I will use this in such a way that in place of this 10 power 2m minus 1, I'm going to write this, just club this. So 10 power 2m minus 1 will be 11d minus 1, isn't it? Okay, so this I'm going to write it as 11 times d minus 1 into this is 10 square, that is 100 plus 1. Is it clear? Please note down this very important step. Now let us further simplify. So this is nothing but 11d minus 1 into 100, 10 square is 100 plus 1. So this is nothing but if you multiply, you will get 11 in 1100. 11 into 100 is 1100d minus 100 plus 1. So this can be further written as 1100 into d minus 100 plus 1 will give me minus 99. I have to prove this is divisible by 11. So please, what I'm going to do it is I'm going to write it as in terms of 11 into something. So I can write it as 11 into 100d minus 11 nines are 99. Is it clear? So this is nothing but 11 into some constant lambda, where lambda, what is actually lambda? Lambda will be equal to 100d minus 9. This will definitely belongs to the natural numbers. Okay, so this is divisible by 11. So is it clear how did we get? So we have concluded, we have started with p of m plus 1 what we wanted. We have concluded even that is divisible by 11. Hence we can say p of m plus 1 is true and conclude with the final conclusion. Well students, this will be the final conclusion for this question, which will conclude all the questions which I had planned to solve for you from this chapter. There are quite few more questions which I'm supposed to solve, which are similar to what I've already solved till now. Okay, so at the end of this session, I'm going to give you the pics of those questions with the solution which I have not solved because they are similar to these steps. Since you're already thorough with this kind of questions, any similar questions, I believe you can easily solve by your own self. Okay, but whatever it is, I've provided the solution for them also. So all the complete exercise questions are solved and the solutions are attached at the end of this video. Kindly watch it and take this to your notes. Well students, that was all about the concept of mathematical induction. Hope you have enjoyed it and also learned the concept in detail. Okay, hope and don't forget to share this video with all of your friends so that even they may be benefited from this. I will be excited to hear your comments about this video from the comment box. Finally, I'm going to say bye to you. We will meet once again in the next video with the next chapter with the different exercise. Until then, take care of your health. God bless you all and bye.